Hello, my dear students. Welcome to one more interesting lecture for you. In this lecture, we discuss difference of two sets, symmetric difference, complement of a set, practical problems on union and intersection of two sets. Okay, thank you. Let's start the session. Now, what is difference of two sets? How to find difference of two sets? Difference of two sets means, for example, in the real numbers, difference of 3 and 2, we mean that 3 minus 2, that is 1. Similarly, how to operate difference of two sets in set theory. The difference of two sets A and B in this order is the set of elements which belong to A but not B. That is denoted by A minus B. Okay, difference of 3 and 2 means 3 minus 2. Similar way, difference of any two sets A and B is denoted by A minus B, and A minus B equals to set of all those elements X which are belong to the set A and not belong to set B. Similarly, B minus A equals to set of those elements X such that X belongs to B and X not belongs to A. So those elements which are belong to B but not belong to A is denoted by B minus A. Those elements which are belong to A but not B is denoted by A minus B. As from Venn diagram, how we represent A minus B and B minus A using Venn diagram. Suppose say this is universal set and take A and B are two subsets of universal set. So A minus B means here this shaded part. So shaded part we mean that collect the elements only A subtracting B part from A. See, this is a part of A and B. You need to remove this part from the set A, then we get A minus B. Similarly, B minus A, those elements which are present in B, not in A. So this is the set B. Here we have to subtract the intersection part. B minus A equals to shaded part as shown in the Venn diagram. Then one example, when two sets A and B are given, how to find A minus B and B minus A practically. For example, this is set A 1, 2, 3, 4 and set B 2, 4, 6, 8. Then A minus B means you have to collect the elements of A which are not present in the set B. For example, see, this is the element 1 which is present in A, not in B. So that you have to include 1 in A minus B. 2, it is there in B also. No need to take. Again, 3 is the element which is present in set A, not in set B. 4, again it is also there in set B. So A minus B equals to set of 1, 3. Similarly, B minus A, those elements which are present in set B, not in set A. Present in set B, not in set A. See, for example, 2 is there in set B as well as set A. Don't take 2. And 4 also in set B as well as in set A. But 6, 8, these two elements which are exclusively present in B but not in A. So B minus A equals to 6, 8. I hope you understand how to find A minus B and B minus A when two sets are given. Now, next point, symmetric difference of two sets. Symmetric difference of two sets. What is symmetric difference of two sets? For example, A and B are any two sets. The symmetric difference of A and B is denoted by A delta B. This symbol is, you have to read delta. The symmetric difference between A and B is denoted by A delta B, and A delta B is defined as A minus B union B minus A. A delta B equals to A minus B union B minus A. Or one more formula also there for A delta B, that is A delta B equals to A union B minus A intersection B. For example, this is set A and this is set B. This is universal set. A delta B means A minus B union B minus A. See this shaded part in set A, this is A minus B, that already we know. This is A minus B. This is B minus A. Union means he has to collect both the parts. A minus B union B minus A is A delta B, or one more formula, same shaded part we get from A union B minus A intersection B also. A union B means total part. There you have to separate the common part. This common part is A intersection B. If you separate this common part from total A union B, that is also same as A delta B. So A delta B has two formulae. One is A minus B union B minus A, and other is A union B minus A intersection B. With one example I'll discuss. Suppose A equals to 1, 3, 4, 5 and B equals to 3, 5, 7, 9. Already it is there on the screen. Then A minus B, those elements which are present in A, not in B. 1 is the element which is present in A, not in B. 3, both A and B it is there. 4 again, it is only present in A, not in B. So that A minus B equals to set of 1, comma 4. B minus A, those elements which are present in B but not on A. So B minus A equals to 7, comma 9. Then A delta B equals to 1, 4, 7, 9 because A minus B union B minus A. Or for example, what is A union B? A union B means you have to collect the elements from both set A and set B without repetition. 1 is there, 3 is there, 4, 5, 7, 9. Fifth one, A intersection B. A intersection B means common elements 3, comma 5. From this formula also, A delta B, again in the formula, A union B minus A intersection B gives A union B means 1, 3, 4, 5, 7, 9 minus A intersection B 3, comma 5. If you remove, then 1, 4, 7, 9. See, already A delta B contains same elements 1, 4, 7, 9. Here also we get 1, 4, 7, 9. So you can find A delta B by using two formulae, using A minus B union B minus A, or A union B minus A intersection B. Now, come to one more, complement of a set. What is complement of a set? Let mu be the universal set and A is any subset of mu, because all sets are subsets of superset universal set. So mu is universal set and A is subset of mu, then the set of all elements of mu which are not the elements of A is called complement of the set A, denoted by A dash or A complement. A complement equals to mu minus A. You have to remove those elements which are present in A from the universal set. Mu is called A complement. It is mu minus A. A complement equals to mu minus A. By set builder form, A complement or A dash equals to set of X such that X belongs to mu and X not belongs to A. It is same as mu minus A. Example, if A equals to 2, 3, 4, 5 and mu equals to 1, 2, 3, 4, 5, 6, then A complement equals to mu minus A, 1, 2, 3, 4, 5, 6 minus 2, 3, 4, 5. Then we get the elements 1, comma 6, exclusively these two elements which are present in mu but not in A. Now from Venn diagram, mu minus A means you have to remove A from mu. We have to remove A from mu. So mu minus A is shaded part, which is exclusively means outside of A but inside mu. This is A complement. Now properties of complement of sets. First one, A union A complement equals to mu, because A and mu minus A, which gives A only. A union, which gives, mu only. A union A complement equals to mu. A intersection A complement, A and not A, there is no any intersection elements. So that A intersection A complement is always phi. These two properties are called complement laws. A union A complement equals to mu. A intersection A complement equals to phi. And A union B whole complement equals to A complement intersection B complement. A union B whole complement equals to mu minus A union B, that is A complement intersection B complement. A intersection B whole complement equals to A complement union B complement. A intersection B whole complement equals to A complement union B complement. These two properties are called De Morgan laws. These two are called De Morgan laws. Now, double complement property. What is double complement property? A complement whole complement equals to A. A complement whole complement equals to A. Why? Because A complement is mu minus A. A complement whole complement means again mu minus A, which gives again A. And phi complement equals to mu minus phi, that is mu. Mu complement equals to mu minus mu, that is phi. All these properties you try using Venn diagram. Venn diagram means take one universal set as rectangle and take a set A, circle, then apply these properties which are true or false, you can easily find using Venn diagram. Okay, understand? These properties are important to you while solving the problems. Now, practical problems on union and intersection. Practical problems on union and intersection. That A and B are any two finite sets, then this is the formula, very important. N of A union B equals to N of A plus N of B minus N of A intersection B. N of A union B equals to N of A plus N of B minus N of A intersection B. If A intersection B equals to 5, then N of A union B equals to N of A plus N of B. Why? Because see, this formula, which is very important, we can prove by using Venn diagram. N of A union B means total elements. For example, see, this is set A, this is set B. N of A means this whole set. N of B means this whole set. Okay. But A intersection part is repeated twice. In N of A, it is covered, as well as in N of B also it is covered. 2 times we have included. So 1 time you subtract. N of A union B, N of A plus N of B minus N of A intersection B, because A intersection B part is covered in set A, again in set B. 2 times we are added. So 1 time we subtract. Then N of A union B gives N of A plus N of B minus N of A intersection B. If A intersection B equals to 5, A intersection B equals to 5 means there is no common element in set A and set B. That is, A comma B are exclusive sets, mutually exclusive sets. Then N of A union B means this shaded part. Here there is no any intersection part. Then directly N of A union B equals to N of A plus N of B. Then directly N of A union B equals to N of A plus N of B. Similarly, if 3 sets are given, then N of A union B union C we can find by using this formula. N of A union B union C equals to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A plus N of A intersection B intersection C. N of A union B union C equals to n of a plus n of b plus n of c minus n of a intersection b minus n of b intersection c minus n of c intersection a plus n of a intersection b intersection c. Now, one example. If A and B are two sets such that A union B has 40 elements and A has 28 elements, B has 22 elements, then how many elements does A intersection B have? Okay. So, write in mathematically, A and B are two sets. A union B has 40 elements means number of elements in union set. So, n of A union B equals to 40 is given. A has 28 elements, we mean that n of A equals to 28. B has 22 elements, we mean that n of B equals to 22. Finally, what he is asking, how many elements does A intersection B have? A intersection B have, how many elements he is asking? So that he is asking to find n of A intersection B. By the formula, n of A union B equals to n of A plus n of B minus n of A intersection B. N of A union B equals to 40, n of A 28 plus 22 minus n of A intersection B. It gives n of A intersection B equals to 28 plus 22 is 50 minus 40, then it is 10. N of A intersection B equals to 10. Okay, that's today's lecture. I hope all of you understand this lecture very properly. In the next lecture, we discuss intervals and wavy curve method with interesting problems. Okay. Bye, all of you. Have a nice day. Thank you. Thank you, one and all.